Now let's see this theorem, Lagrange's mean value theorem. Let f of x be defined in the interval a comma b such that it satisfies two conditions. First condition is f of x is continuous in a comma b. Second condition is f of x is differentiable in the range a comma b. Then there exists at least one point c which belongs to a comma b such that f dash of c equal to f of b minus f of a divided by b minus a. So what they are trying to say is, if you have a function like this, let us say you have a function like this, okay, and now assume that we are talking about the range a comma b in such a way that, let us say this is a and maybe this is b, okay, so this is a and this is b. Now within this range two conditions have to be satisfied. First condition is f of x is continuous, it should be continuous, and the second condition is f of x is differentiable in the range a comma b. So if you see this, it is definitely continuous between these 2 points as well as is differentiable. There are no holes, there are no jumps, that is why it is continuous, and there are no corner points or the vertex points, so therefore it is differentiable. Now they are saying that there should exist at least one point in such a way that f dash at that point, which means the slope of the tangent drawn at that one, is equal to f of b minus f of a divided by b minus a, which is nothing but, see, if you write this point, this line, what is this point? This point is b comma f of b, isn't it? Now what is this point? This point is a comma f of a. Now what will be the slope of this line? The slope of this line is going to be y2 minus y1 divided by x2 minus x1, isn't it? Therefore the slope of this line is f of b minus f of a divided by b minus a, right? And the slope of tangent at this point is f dash of c. Let us say this point is c, okay. Now what they are trying to say is, if you have any function defined like this, now there will definitely exist a point on the function in such a way that the tangent drawn at that point will be parallel to the line joining these 2 points, which means the slope of this line and the slope of this line both are equal. What is the slope of the tangent drawn at c? F dash of c. What is the slope of the line joining these 2 points? y2 minus y1 divided by x2 minus x1. So this is what they are saying, right? So now if you see the relationship between this one and the earlier Rolle's theorem, you can see that the Rolle's theorem is nothing but this one, in which Rolle's theorem has only discussed about one case where these 2 values are equal. What happens when these 2 values are equal? When these 2 values are equal, this line joining these 2 is nothing but the line parallel to x-axis. Therefore, in that theorem they were talking about the existence of a point which is parallel to x-axis, and in this theorem we are talking about existence of a point at which the tangent is parallel to the line joining these 2 points. Got it?